Hi, this is a paper walkthrough for the Edexcel GCSE Maths Paper 1 Higher from 2022. For each question, I will try and give a detailed explanation of how to get the solution, along with a quick look into which topics are involved, so that if you've struggled on a particular question, you know which topics to revise to do better on similar questions in the future. So the first question in this paper is about inequalities. So these are effectively a slight difference from equations, where rather than saying that two different terms are equal, we're saying that one is larger than the other or one is smaller than the other. So in this case, we have 7x minus 27 is smaller than 8. And in general, we can treat inequalities like equations as long as we remember that there are some slight differences. So we can use all the same techniques that we use for equations as long as we remember the implications of what we're showing is not the same as saying this thing is equal to this thing. So here we have 7x minus 27 is smaller than 8. And as we do with equations, we can move things around by adding and subtracting. And we have to do that, of course, to both sides. So as we do normally, if we have something taken away, then to get rid of it, we add it to both sides. Similarly, if we have something added, we take it away from both sides, and we can do similar operations for multiplications and divisions. So the first thing we want to do is get all of our x terms on one side and all of our regular number terms on the opposite side. So to do that, we want to get rid of the 27 on the left-hand side, and so we add 27 to both sides. That's going to leave us with 7x is smaller than 35. And now, of course, we have x multiplied by something related to something else, and we want to eventually solve for x, or at least an inequality in x. And so our final step is to divide both sides by 7. Obviously 7x divided by 7 goes to x, and 35 divided by 7 is 5. So our final answer for this question is x is smaller than 5. Okay, so question 2 is talking about prime factorisation. This is a very useful way of representing larger numbers as the product of a group of smaller numbers that are all prime. So we do this question by making a prime factorisation tree. That is, we start with our large number and then we find pairs of numbers that multiply together to make that number. And as we move down the tree, we want to continue finding pairs that multiply to the number above until all we're left with at the bottom of the tree is prime numbers. So in this case, we can see 124 we can make by multiplying 2 by 62. 2 is a prime number, so this branch ends here. 62 not a prime number, so we then find that 62 we can do 2 multiplied by 31 gets 62, and then all of these numbers now at the bottom are prime numbers, and so we can stop there, and so we can say 124 equals 2 squared, so it's just 2 times 2 times by 31. A small note, it's generally accepted that we should write these in increasing order of numbers as we go along, so 2 squared times 31, not 31 times 2 squared. Question 3 involves two different topics. We have ratios and we have fractions. So it says a delivery company has a total of 160 cars and vans. The ratio of the number of cars to the number of vans is 3 to 7, and each car and each van uses electricity or diesel or petrol. 1/8 of the cars use electricity, 25% of the cars use diesel, and the rest of the cars use petrol. And we want to work out the number of cars that use petrol, and we must show all of our working. So this question is effectively in two parts. We have the ratio part at the start, which is to figure out the number of cars that the company has, and then we have the fraction part, the second half, to actually figure out how many of those cars use petrol. So in the ratio part, remember that we can think of ratios as a way of splitting up larger things. So in this case, it's the fleet of the delivery company, and we can find the total number of parts in the ratio, what we're splitting things up to, by adding the numbers in the ratio. So 3 plus 7 is 10, and then we can use that to say, okay, 3/10 of this fleet is made up by cars, and 7/10 of this fleet is made up by vans. So to find out the number of cars the company has, we need to find 3/10 of 160. So we can say that 1/10 of the fleet is just going to be 160 divided by 10, so 16, and then 3/10 is going to be that 16 multiplied by 3, which gives us 48 cars. So that's the ratio part of the question finished. Now, in this second half of the question, we're given the information for the fraction part. We're given what fraction of the cars use electricity, what fraction use diesel, and we're told that the rest of the cars use petrol. We're not actually given the fraction. Now we know that the fraction of the cars that use different fuels must add up to 1 because we must account for all of the different fuel types. So we can say that 1/8, the fraction of the cars that use electricity, plus 1/4, the fraction of the cars that use diesel, plus x, which is going to be the fraction of cars that use petrol, is going to equal 1. By quickly rearranging this, just subtracting 1/8 plus 1/4, which is equal to 3/8 from both sides, we can see that x equals 5/8. So 5/8 of the cars use petrol. So again, we want to find 1/8 of 48, our number of cars. We get obviously 6, just divide 48 by 8, and then we find 5/8 by multiplying our 6 by 5, so we get that 30 cars in the fleet use petrol. Okay, so all of question 4 is about standard form, but particularly 4a involves turning a standard form number into an ordinary number. So remember, of course, that any standard form number has got two parts. We've got the leading factor that's always between 1 and 10, and then we've got the second factor that's always a power of 10. So this effectively tells us the size of the number, the second factor, and the first factor effectively tells us exactly what number we're looking at. So first of all, we can see that 10 to the power of minus 3 is going to be 0.001. If we think, we can always start from 10 to the power of 0, just being 1, and then we can go leftwards for positive powers or rightwards for negative powers. So we just go back 1, 2, 3. So that's where our 1's going to be for just 10 to the power of minus 3. Then obviously we're just going to multiply this, as we've done here, by 1.63. And that's obviously very simple to just sort of change those digits. So we have 0.00163. 4b is the opposite way round to 4a. Instead of changing a standard form number into a regular number, we want to change a regular number into a standard form number. So looking at 438,000, we can see that it's got 6 digits. And quite confusingly, this means that it's actually related more to 10 to the power of 5. And if we remember that 10 to the power of 1, 10, obviously has 2 digits, we can understand where that small discrepancy comes from. So obviously we can imagine if we add the 1 here, it'd be 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5. So starting at the very where the decimal point would be normally, if we count along 5 digits, we can see where the decimal point should go when we make this into a standard form number. So we go 1, 2, 3, 4, 5. So we can see that the decimal point should go between 4 and 3. So the way we write this number in standard form is 4.38 times 10 to the 5. Obviously, for different standard form numbers, you might have more significant figures here, more non-zero numbers, and you would have to write either 4.38 something, or if the question asks you to write it to a certain number of significant figures, you then have to obviously make that determination as you're doing the question. Part C of this question involves taking two standard form numbers and multiplying them together to make a third standard form number. The important thing to remember when doing these sorts of questions is that we can treat the different parts of standard form numbers completely separately. So instead of doing 4 times 10 to the power of 3 times 6 times 10 to the power of minus 5, we can do 4 times 6 times 10 to the power of 3 times 10 to the power of minus 5. Bring it all together in the end and get the right answer. So of course 4 times 6 equals 24, and using our indices rules, 10 to the power of 3 times 10 to the power of minus 5, we add the powers, so we get 10 to the power of minus 2. Finally, we remember that for standard form numbers, we need our first term to be between 1 and 10. So we simply make this term 10 times smaller and make this term 10 times bigger, and we'll be left with the same number. So obviously dividing 24 by 10, we get 2.4, and multiplying 10 to the power of minus 2 by 10, we get 10 to the power of minus 1. So our final answer is 2.4 times 10 to the power of minus 1. This question is all about our knowledge of polygons and angles within polygons. So we have a regular hexagon and a regular pentagon, and we have in between them the angle x. And we must find the size of the angle x and show all that working. So, of course, a hexagon has 6 sides, and we remember from the equation that the total angles of a polygon is the number of sides, subtract 2, times by 180. Obviously, in that case, 6. In this case, 6 minus 2 equals 4 times 180 gives us 720 degrees total internal angles. Now, this is a regular hexagon, which means that all sides are the same length and all angles are the same size. So to find one interior angle, we just need to divide the total by the number of angles. So that's 720 divided by 6 gives us 120 degrees. We can do this again for a pentagon and find we have 5 sides, so total angles 5 subtract 2 times 180, obviously 3 times 180, 540 degrees. And again, it's a regular pentagon, and so each angle is going to just be 1/5 of the total angle. So 540 divided by 5 gives us 108 degrees. So we know that this angle here must be 120 and this angle here must be 108. And of course we know that angles around a point add to 360 degrees. So 120 plus 108 plus x, which is our unknown angle, equals 360. Obviously, subtracting 120 and 108 from both sides of this equation, we can find that x is equal to 132 degrees. Question 6 is another multi-parter, and part A is rather simple. We're just asked to complete the table of values for y equals x squared minus 3x plus 1. So this question is based on the topic of quadratic equations. So for the missing values, x equals minus 1, x equals 2, 3, and 4, we simply have to fill in the value of y. And so we do this over here. We have for x equals minus 1, we do minus 1 squared minus 3 times minus 1 plus 1, which then gives us minus 1 squared, of course, 1. 3 times minus 1 is minus 3, but this is obviously a minus in front, so that becomes plus 3. And obviously the plus 1 remains the same, which gives us a value of 5. Then for x equals 2, we do 2 squared minus 3 times 2 plus 1. 2 squared obviously makes 4. Minus 3 times 2 minus 6, and plus 1 remains the same to give us minus 1. For x equals 3, we have, of course, 3 squared minus 3 times 3 plus 1. Obviously, the 3 squared and the minus 3 times 3 make 9 and minus 9, which cancel out to make 0, and we're just left with the plus 1. And finally, we have x equals 4, and of course, we do 4 squared minus 3 times 4 plus 1, which leaves us with 16 minus 12 plus 1, which leaves us with 5. Part B of question 6 now asks us to use the table of values we have just made to plot the graph of this equation between the x values minus 1 and 4. And so using the table of values down here, we're going to look at each pair of x and y coordinates to plot points. So here, 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 and here. And then we're going to connect up these points. Now, what would be an okay way to do this would be to connect up each pair of points with a straight line. But given that we know the approximate shape that this graph is going to take on from it being a quadratic equation, it's better to try and draw a curve. Now, obviously, in an exam with a pen or a pencil, this is going to be considerably more difficult. So I would suggest using a pencil, giving it a go, rubbing it out if needed, giving it a few tries, seeing how you can do best to connect up all these points in a nice curve like this. Obviously, things we're looking for, we should see a minimum point here in between x equals 1 and x equals 2. Part C of question 6 asks us to use the graph we have just sketched to find estimates for the solutions of the equation where our quadratic is equal to 0. Very simply for this, we're going to look at the points where the graph intersects the x-axis, because of course at the x-axis, y is always equal to 0. So we look for these two intercept points, we draw a little line through them, and we can see that the first one is x equals 0.4, and the second is x equals 2.6. So our two answers are 0.4 and 2.6. Question 7 gives us two cubes A and B, one with side length 3 centimeters, one with side length 4 centimeters, and the mass of cube A is 81 grams, and the mass of cube B is 128 grams. And we're asked to work out the ratio of the density of cube A to the density of cube B, and give that ratio in a form such that both elements are integers. So, to find density, we need to divide mass by volume. We already have the mass of both cubes, but we don't have the volumes. The volume of a cube is just the side length cubed, and so we can calculate that the volume of cube A is 3 centimeters all cubed, which gives us 27 centimeters cubed. and for B, it's 4 centimeters all cubed, gives us 64 centimeters cubed. We can then work out the density of A is 81 grams divided by 27 centimeters cubed, which is 3 grams per centimeter cubed. And the density of B is 128 grams divided by 64 centimeters cubed, which gives us 2 grams per centimeter cubed. So the ratio of these densities, of course, is just 3 to 2. So question 8 is looking at data visualization, in this case, frequency tables. So we're given a table showing the amount of snow in centimeters that fell each day for 30 days. So we've got the amount of snow in centimeters here, and we've got 10 centimeter wide intervals ranging from 0 all the way to 50. And for each interval, we have the frequency, the number of days on which that much snow fell. And we're asked to work out an estimate for the mean amount of snow per day. So of course the mean is equal to the sum of all of our data points divided by the number of our data points. And the important thing to realize here is that we don't actually know the amount of snowfall we have each day. So for example, on one of these 8 days, we don't know whether 2 centimeters of snow fell or 8 centimeters, we just know that it's somewhere in here. So an assumption we have to make in calculating this estimate is that the snowfall for each day is the midpoint of the interval that it lies in. So for example, for each of these 10 days, we're going to assume that 15 centimeters of snow fell, and for each of these 3 days, we're going to assume that 45 centimeters of snow fell, and so on and so forth. So to calculate the mean snowfall, we do 5 plus 5, 8 times, and then do 15 added together 10 times, and obviously that's just a proxy for multiplication. So we can shorten this down quite a lot and say it's 8 times 5 plus 10 times 15 plus 7 times 25 plus 2 times 35 plus 3 times 45. And obviously you can see here we just work through that addition on the numerator. Obviously there's many different ways you could do this. This is just the way that I did it in a non-calculator fashion. And we end up with 570 divided by 30, which is 19 centimeters, is our mean snowfall per day. So question 9 puts together two 3D shapes to make a compound 3D shape. So this question is on compound shapes and surface area. So we have a cube of side length 4 centimeters placed on top of a cuboid of side length 7, 6, and 5 centimeters. And we're asked to work out the total surface area of this solid. So first, looking at the cube, we have 5 completely exposed faces and 1 completely covered surface. So the area of each face is obviously 4 times 4 centimeters. This gives us 16 centimeters squared, and we have 5 of those exposed faces. That gives us a total cube surface area of 80 centimeters squared. The cuboid has 2 exposed 6 by 5 centimeters faces, so this one here and this one here. So that's 2 times 6 times 5 is 60 centimeters squared. 2 exposed 7 times 5 centimeter surfaces, so this one at the front, this one at the back. 2 times 7 times 5, 70 centimeters squared, and then 1 exposed 7 times 6 centimeter surface. So that gives us 42 centimeters squared. Finally, we have this top face that is partially exposed. So obviously that has a surface area, if it was completely exposed, of 42 centimeters squared, but it's covered by the 16 centimeters squared of one of these cube faces. So the exposed area is 42 minus 16 equals 26 centimeters squared. So the total cuboid surface area is 60 plus 70 plus 42 plus 26, which gives us 198 centimeters squared. And then adding the cube surface area to the cuboid surface area, we find the total surface area of the solid is 278 centimeters squared. So question 10 is another multi-parter, and we're shown a table with the information about profit made each day at a cricket club over 100 different days. And we're given profit intervals 0 to 50, 50 to 100, and so on to 250 to 300. And first of all, for part A, we're asked to complete a cumulative frequency table. So we notice that in this first frequency table, each interval is distinct. So we have 0 to 50, 50 to 100, and so on. Whereas in a cumulative frequency table, we're looking at the frequency of all intervals up to now. So this first one is just 0 to 50 again, but then the second one is both the 0 to 50 interval and the 50 to 100 interval to give us this 0 to 100 interval. So the cumulative frequency in each row is equal to the sum of all previous frequencies. So we can find that the frequency. The cumulative frequency for the first interval is just the same as in the regular frequency table, that's just 10. For the second, it's the 10 we already have plus the 15 of the this next interval, so that's 25. For the 0 to 150, we add in 25, which gives us 50. Then for the 200 interval, we add in 30, which gives us 80. For the 250 interval, we add in 5, which gives us 85. And finally, for the 300 interval, we add in 15, which gets us up to 100. Now that's a good little checksum there, basically, that cumulative frequencies should end up at the value that the size of the entire data set. So in this case, it's 100 days, and we can see our final cumulative frequency is 100. So part B of question 10 asks us to use the cumulative frequency table we've just used to draw a cumulative frequency graph. So this is just another way of presenting the same data, and using this table we're just going to plot the points that we've got. So for a profit of £50 or under, we've got 10 days. For £100 or under, we've got 25 days, and so on and so forth of the graph. So we're just going to plot those points and then connect each pair of points with a straight line. Now, an important note here is that we are using the end of each interval for where we actually mark the points, and that is because, of course, if we look back to our table, we can say that we only know that the cumulative frequency will reach 10 once we've got up to £50 of profit, because one of these days could be £49 of profit. And so if we use the midpoint, for example, 25, then we would obviously miss out some of these days that we're supposed to be counting. So this is the graph we obtain in the end. And of course, a good little check is that our graph should end up at the final profit interval, which obviously is 300, and the total number of days, which is 100. So part C of question 10 is asking us to extrapolate data from a graph we've already got. So we're asked to use the graph we've just drawn to find an estimate of the number of days on which the profit was less than £125. So here we're looking at the part of the data sort of to the left and down of our £125 profit. And so we draw a straight line up from £125 to the graph, and then go across to find out what our cumulative frequency would be at that profit. And so obviously if we draw across here, we come to 38 days. So the answer, the number of days on which the profit was less than £125 is 38 days. And finally, part D of question 10 asks us to use this graph to find an estimate for the interquartile range. So if we order a data set from minimum to maximum, we can obviously see that the first data point will be the minimum, the last data point will be the maximum, and we can actually come up with a new measure of average by taking the middle data point, and that is our median. Now from that we can make some more measures. If we go 25%, a quarter of the way along, we can make what's called a lower quartile, and if we go 75% of the way along, or 3/4, we can get the upper quartile. So these are effectively measures of where the bottom 25% of the data set is and where the top 25% of the data set is. And we have another measure called the interquartile range that effectively asks us how spread out the middle 50% of the data is. And that's just the difference between the upper quartile and the lower quartile. So here we have 100 days, so the lower quartile will just be at 25 and the upper quartile at 75. So we draw across from our cumulative frequency of 25 and 75 to the line, and then draw down to see what profit that corresponds to. So for our lower quartile, 25, that is £100, and for our upper quartile, that is £192.50. So our interquartile range is upper quartile minus lower quartile, 192.5 minus 100, which means £92.50 is our interquartile range. So question 11 is talking about ratios and probability and how they interact. So we're told there are some sweets in a bag that are either lime flavored, strawberry flavored, or orange flavored, and they're in the bag. The ratio of the number of lime flavored sweets to the number of strawberry flavored sweets to the number of orange flavored sweets is 9 to 4 to x. And we're also told that if we take a random sweet from the bag, the probability of taking a lime flavored sweet is 3/7. And we're then asked to work out the value of x. So I've shortened this here to L to S to O for lime, strawberry, and orange is 9 to 4 to x. Now how we can use this mix between probability and ratios is that the probability of picking one element from a ratio is that the prominence of that element, which is in this case 9, divided by the sum of all elements. So in this case, our 3/7 chance of picking a lime sweet is equal to 9 divided by 9 plus 4 plus x, the sum of all these elements. So we can now rearrange this to solve for x. First multiplying both sides by 9 plus 4 plus x to get this out of the denominator. So we get 9 equals 3/7 times 9 plus 4 plus x. Then we can multiply both sides by 7/3, which will get rid of this fraction here because 7/3 times 3/7 is 1. And so we have 21 equals 13 plus x. Finally, we can subtract 13 from both sides and we obtain 8 for our answer for x. Question 12 is looking into the topic of recurring decimals and asks us to express 0.117 recurring as a fraction. So in my working out here, I've used a simple notation where any digits in brackets are recurring, and that's simply just due to the limitations of how I'm expressing this. So we have 0.117 recurring is equal to x. Now this first step here is by far the most important. Whenever you're trying to do these sorts of questions, the trick is we need to multiply by a power of 10 such that we shift over by one recurrence. So when I say a recurrence, I mean an instance of these recurring digits. So here, by multiplying x by 100, you can see that I've moved the whole number basically left along such that the recurring 17 is in the same position as the recurring 17 is in our regular x. So we have 100x equals 11.7 recurring 17, and then x is equal to 0.1 recurring 17. So you can see now that if I subtract this x from this 100x, obviously I just get 99x on the left-hand side. When on the right-hand side, the recurring 17s obviously cancel out, and then we just left with 11.7 subtract 0.1, which gives us 11.6. We can then rearrange this. We can divide both sides by 99 to get x is 11.6 divided by 99. But of course, to express it as a proper fraction, we need integers as both the numerator and denominator, so we can just multiply by 10 to get 116 divided by 990. An important thing to note is that we're not asked to express this fraction as the simplest fraction we can, we're just asked to express it as a fraction. So we could even multiply this by 20 or 30 and we'd still have the right answer. Of course, in this case, multiplying by 10 is the simplest way to get a correct fraction. So question 13 is looking into algebra and also our knowledge of right-angled triangles, specifically using Pythagoras theorem. So we have a right-angled triangle being formed by the diameters of three semicircular regions, capital A, capital B, and capital C, as shown in this diagram. And our objective is to show that the area of region A is equal to the area of region B plus the area of region C. So if we look over here, we're going to use the notation that little a is equal to the side length of the right angled triangle side that borders region capital A, and etc. So little b is the side length here that borders region capital B, and little c is the side length here that borders region capital C. The area of a circle we know is pi r squared, and so the area of a semicircle, obviously just being half of a circle, is a half pi r squared. So the area of capital A is going to be a half times pi times a divided by 2 all squared. A divided by 2 because obviously a is the diameter of this region, and so the radius is just half that, which is of course a divided by 2. So if we multiply this all together and expand these brackets, we're going to have a half times pi times a onto all squared, which is going to give us a squared divided by 4. So putting that all together, we have pi times a squared divided by 8. Now using similar maths to what we've just done here for area A, we can show identically that the area of B is equal to pi times b squared divided by 8, and the area of C is pi times c squared divided by 8. So we could write that the area of B plus the area of C is pi divided by 8, taken out of the brackets, and brackets b squared plus c squared. Over here we've justified obviously that A is the hypotenuse of this right angle triangle, and so from Pythagoras theorem, a squared is equal to b squared plus c squared. So here in our equation where we have b squared plus c squared, we can substitute in a squared. And so we have the area of b plus the area of c equals pi divided by 8 times a squared. And we know from up here that this expression, pi times a squared divided by 8, is equal to the area of a. And so we can say that the area of b plus the area of c equals the area of a. And this QED at the end basically just means so we have proven what we set out to prove. So question 14 is another multi-parter, and 14a is looking at finding the gradient of a graph. And the way that we do this, the way that we find a gradient of the graph, is using what's called the tangent method. So this question specifically asks us to work out an estimate of the gradient of this graph at time equals 2. And so we use the fact that the tangent of a graph will have the same gradient as the graph at the point it is tangent at. So in this case, we want to draw a tangent to the graph that is a line that touches the curve at one point and one point only. And we draw that tangent at 2 seconds, of course. And then if we can calculate the gradient of that line, of course the gradient of that line is the same as the gradient of the curve at that point, and therefore we have our answer. So I have drawn a tangent line and made it nice and long, which means that we have basically a larger set of data that we can look at, and then we can calculate its gradient. So we can see that along the length of this line, its length is 5.1 seconds, using obviously the time scale here, and its change in height is 5.2 meters per second. Then use the equation that gradient is equal to rise over run, or change in y divided by change in x, which is equal to 5.2 meters per second divided by 5.1 seconds. Now the important word again here is the word estimate, which means that in this non-calculated paper, we're not being expected to divide 5.2 by 5.1 to say 52 over 51 meters per second squared. We can simply say this is close enough to 1, this fraction, that we can say, using this approximately equal symbol, we can say that the gradient here is approximately 1 meter per second squared. Question 14b entails a part of this GCSE that you're just going to have to memorize, and that is the relationship between the 3 types of movement graphs we can be given: distance time graphs, velocity time graphs, and acceleration time graphs. So we can see along this list, taking the gradient of these graphs takes us down one space on the list, and taking the area under these graphs over a certain interval brings us up 1 on this list. So here we're taking the area of a velocity time graph, and so we're going to get the distance travelled in the given time interval. So 15 is another multi-part question that deals with vectors. Now this question may look quite difficult at the outset because it is talking about vectors entirely algebraically. There's no diagrams, there's no shapes to look at, and there's no arrows drawn down. So the important thing to think about when approaching these sorts of questions is just to treat vectors as another part of algebra. They're not exactly the same as algebra, normal algebra problems, but they are to be thought of as an extension of algebra. So we're given that A, B, and C are 3 points such that the vector connecting A to B is equal to 3A plus 4B, and the vector connecting point A and point C is equal to 15A plus 20B. And for part A, we're asked to prove that A, B, and C lie on a straight line. So we can spot quite quickly that AC is just equal to 5 times AB, and this is where that algebra element comes into it. And this is an important identity to remember regarding vectors, is that if we scale a vector by a positive number, so in this case AC equals 5 times AB, then the vector points in the same direction. And so we can say from this that the line from A to B points in the exact same direction as the line from A to C, and of course both lines originate at the same point. So we can imagine that the line from A to B is actually just a subset of the straight line from A to C, and therefore A, B, and C lie on a straight line. And again, this QED is just to say we have proven what we set out to prove. So part B goes in a slightly different direction, where we're told that D, E, and F are 3 points on a straight line, such that the vector from D to E is equal to 3E plus 6F, and the vector from E to F is equal to minus 10.5E minus 21F. And we're asked to find the ratio between the length of the line DF and the length of the line DE. Now, the important thing to realize immediately is that we're not given the vector DF. So what we have to do is calculate that ourselves. Vectors, of course, are just like instructions of how to get from one point to another. So if we follow multiple instructions in a row, where the end of one instruction is the start of the next, we will go from the very start of the first to the end of the last. So in this case, if we do DE and then EF, we will go from D to F. And in in the notation of the components, that just is the same as adding those components together. So we do, to get DF, we do 3 minus 10.5e equals minus 7.5e, and 6f minus 21f equals minus 15f, sorry. So df is equal to minus 15f. The length of a vector is simply the square root of the sum of the squares of all of its components. Now that might sound a bit complex, but effectively in this case, it means we need to do the square of the length in E and the square of the length in F. In a lot of other vectors, this would be the square of the length in X plus the square of the length in Y, but obviously this can change depending on what coordinate system you're using. So from this we can see the length of DE is the square root of 3 squared plus 6 squared. And so that's equal to the square root of 9 plus 36, so square root of 45. The length of DF is equal to the square root of 7.5 squared plus 15 squared, which is equal to 281.25. Now, I find it easy to go from fractions to ratios because you can just use the numerator as one element and the denominator as another, the sort of inscribing the same information. So we make a fraction and we can say that the proportion of df to de is equal to square root 281.25 divided by square root of 45. Now this seems obviously incredibly complicated, and it is, but we can simplify this fraction down until we get to some easy numbers to work with and then put that into a ratio. So the first thing we can do here is multiply the numbers in the square roots of the numerator and denominator by 4. Now it's important to remember that what we're actually doing here is multiplying the numerator and denominator of this by 2, but when it goes into the square root sign, it goes the opposite way. So it becomes, rather than being square rooted to square root 2, it gets squared to become 4. And in the same way, if we take something out of the square root sign, it would be square rooted. So by doing that, we get 1125, or the square root of 1125, divided by the square root of 180. Now these are both clearly divisible by 5, so again, we divide what's inside the square root on top and bottom by 5, and we get the square root of 225 divided by the square root of 36. Now this is where remembering square numbers comes into use. You should know the square root of 225 and the square root of 36 as part of your GCSE. And so of course we have 15 divided by 6. We can then obviously move that quite easily into a ratio and say the ratio of df to de is equal to 15 to 6. Question 16 looks at probability, and we're told about a first aid test that has 2 parts, a theory test and a practical test. We're told that the probability of passing the theory test is 0.75 and the probability of passing only one of the 2 parts is 0.36. We're told the 2 events are independent and we're asked to work out the probability of passing the practical test. So before I get into the probability tree I've got down here, an important note is that of course the possibilities in both cases are either that we either pass or fail, and therefore the probability that any of these things will happen is 1. It either must be a pass or a fail. Using this and using that the probability of passing the theory test is 0.75, we can work out the probability of failing the theory test is 0.25, simply 1 minus the other probability. So we can see here, as illustrated in this pass branch and this fail branch with the associated probabilities. Right now, of course, we don't know the probability of passing the practical test. That's what we're going to try and find out. So I've labelled that as our unknown variable p. And again, using this axiom that the probability of all the possibilities must add to 1, we know that the probability of failing the practical test must be 1 minus p. And again, that's illustrated here and here. Now we're given another numerical value that the probability of passing only one of the two parts is 0.36. So we can achieve that either by passing the theory and then failing the practical, or failing the theory and then passing the practical. So we can see that when we end up at the end of this branch or the end of this branch, that's the condition we're looking at, and that adds to a probability of 0.36. So this is basically the end of the utility of the probability tree, and we have to now go into algebra. So we can say that 0.75, that is the probability of going into this branch, times 1 minus p, that's the probability of this branch, plus 0.25, the probability of going down this branch, times p, the probability of going up this branch, must equal 0.36. And we can say this because when we have independent events, that is events that don't influence each other, such as the theory test and the practical test, we can simply work out the probability of one event happening and then another event happening by multiplying the probabilities of those two events. So that's what we've done here. And obviously because either of these ways, up and then down or down and then up, would satisfy our condition, we add them together because the probability of two things happening either or, we just add the probabilities of both of those things. So then we can rearrange this slightly, expand out these brackets to get 0.75 minus 0.75p plus 0.25p equals 0.36. Obviously, there's minus 0.75 and there's plus 0.25. We're going to 0.5p. And if we then subtract this 0.75 from both sides, we end up with minus 0.39. Getting rid of the minus on both sides, so we can say multiplying by minus 1, we get 0.5p equals 0.39. And finally, multiplying both sides by p by 2, we get p equals 0.78. And we can double check this is correct by substituting this into our probability tree, and we then find the probability of passing and then failing is 0.165, and the probability of failing and then passing is 0.195. These two add to 0.36, which is what we were given, so that shows that our answer is correct. Question 17 is about direct and inverse proportion. So we're told that y is directly proportional to the square root of t, and y equals 15 when t equals 9. We're also told that t is inversely proportional to the cube of x, and t is equal to 8 when x is equal to 2. And we're asked to find a formula for y in terms of x in its simplest form. So we can break this problem down into 3 steps. First of all, we need to find a formula linking y and t. Then we need to find a formula linking t and x. And finally, we need to combine these in a way that eliminates t to find a formula linking y to x. So first of all, we can say, of course, that y is proportional, so what this symbol means, to the square root of t. And we can say that y is equal to 15 when t is equal to 9. So we can rewrite this as y is equal to a, which is some constant we don't know so yet, times the square root of t, as I've said, where a is equal to a constant. So we can say 15 is equal to this constant a times the square root of 9. That's using these values we're given here. And so 15 equals 3, that being the square root of 9a. And obviously here we can just solve for a equals 5. And so y equals 5 square root t. For t and x, we can say t, obviously it's inversely proportional, so that's 1 over. T is inversely proportional to x cubed, so it's t is proportional to 1 over x cubed. We know that t is 8 when x is 2, and again we can use this idea when we say something is proportional to something else. We obviously imagine there could be some constant. It could be 1, in which case it doesn't really matter, but there could also be some non-1 constant, and so we have t equals b divided by x cubed. Substituting our values in, we have 8 is equal to b divided by 2 to the power of 3. Of course, 2 to the power of 3 is just 8, so we have 8 equals b divided by 8. And then if we multiply both sides of this equation by 8, we end up with b is equal to 64. And so our equation becomes t equals 64 divided by x cubed. Now to combine these equations in a way that eliminates x, we want to make the subject of both equations t. Now right now, on this side, our y and t equation, y is very much the subject, so we need to rearrange this equation to make t the subject. So first of all, we square both sides and we get y squared equals 25t. Then we divide both sides by 25 to get t equals y squared divided by 25. Now we have two different expressions here for t, and so we can simply say they are equal. Of course, t always has some certain value, and that value must be equal to 64 divided by x cubed, and also must be equal to y squared divided by 25. And so we can say that y squared divided by 25 must be equal to 64 divided by x cubed. Now we want to eventually get y as the subject because we're trying to find a formula for y in terms of x. You could be a bit tempted to multiply 25 over here now to sort of get y more isolated, but that will require quite a big multiplication, and this is a non-calculator paper. So what I'd rather do first is square root both sides and get y divided by 5 equals 8 divided by x to the power of 3 on 2. So if we square root it, we add that denominator of 2 in the power, and then of course multiply both sides by 5 to get rid of this denominator here, and we have y equals 40, that's 5 times 8, x to the power of minus 3 on 2. So you can see here we've just pulled this x from being in the denominator to the numerator, and so we need to make the power negative. Writing it 40 divided by x to the power 3 divided by 2 is just as valid. I've just done it like this so I can write it all in one go. Okay, so question 18 is all about simplifying expressions. So we're given this very horrible looking expression here, 5 and 4/9 to the power of minus a half times 4 and 2/3 all divided by 2 to the power of minus 3. So this is very much a question that we want to tackle one part at a time. So we're going to go through and we're going to simplify each term into something much nicer, and then we can calculate it at the end. So first of all, mixed numbers, as in 5 and 4/9. These are terrible. These are what's going to cause a large number of mistakes, and so we're going to want to get rid of them as quickly as we can. So even at the start here, you can see I've written 5 plus 4/9, because that's what that actually means, to the power of minus a half times 4 plus 2/3, all divided by 2 to the power of minus 3. So immediately we can turn 5 into 45 divided by 9, plus 4/9 obviously, to the power of minus a half, times by, and we've turned 4 into 12 over 3, plus 2 over 3, again all divided by 2 to the power of minus 3. So of course, because these have the same denominator, these two fractions, we could just add the numerator to make it into one fraction, 49 divided by 9 to the power of minus a half. And again, these two fractions have the same denominator, so we can add the numerators and get 14 divided by 3. And of course, that's all divided by 2 to the power of minus 3, which is just the reciprocal of 2 to the power of 3. So 1 over 2 to the power of 3. 2 to the power of 3, of course, is 8, and so 2 to the power of minus 3 is 1 over 8. Now, if we divide by 1 over 8, what we can do there is flip the fraction and bring it to the top. So we can turn this into, rather than being 1 over 8, into just being 8, but of course it comes to the numerator. So we have 8, and then what we've done here for the second term, if we have a negative power, that indicates a reciprocal, so we can get rid of it by flipping the fraction. So we can move the 9 to the denominator, from the denominator to the numerator, and 49 to the denominator, and we end up with 9 divided by 49 to the power of a half, times by 14 over 3. One of our final steps is, of course, power of a half effectively means to square root. Similarly, power of a third would mean to cube root, and so on and so forth. And so, of course, we just square root the top and the bottom. Square root of 9 is 3, square root of 49 is 7. So we end up with 8 times 3 divided by 7 times 14 divided by 3. Now, another important little identity with fractions, if we have a string of multiplication and we have a numerator somewhere and a denominator somewhere that are the same, they simply cancel, because of course we could split this all up into 3 times 1 over 7 times 14 times 1 over 3, and of course that 3 and that 1 over 3 would just cancel to make 1, and then of course we can just combine the 14 here and what would be the 1 over 7 here to get 14 over 7. So we have 8 times 14 over 7. Of course 14 over 7 is just 2, so we have 8 times 2, which is 16. So question 19 is part quadratic equation question and part complex fraction question. So we've got this fraction and this equation here. 1 divided by 2x minus 1 plus 3 divided by x plus 1 is equal to 1. And we're obviously trying to solve for x, and we're giving our answer in the form p plus or minus the square root of q divided by 2, where p and q are integers, so that's whole numbers. So the first thing we need to do to be able to deal with this expression is we need a common denominator. Of course, fractions are really annoying to deal with when they have a different denominator, so we want to make the denominator the same. And we can use one of my favorite tricks with fractions, which is we multiply them by 1, which obviously doesn't change what the fraction is. But when we multiply them by 1, we don't just multiply them by 1, we multiply them by something that's equivalent to 1. So for example, we can multiply this first fraction by x minus 1, like this, on top and bottom. And so, but that's still equal to that's the same fraction, because x minus 1 divided by x minus 1 is just 1. We can do a similar but slightly different thing to this other fraction, multiply top and bottom by 2x minus 1, 2x minus 1 here. And so you can see now that these two fractions have the same denominator, 2x minus 1 in brackets and x minus 1 in brackets. And so now, if we just expand this set of brackets out here to get 6x minus 3, we can see now we've got two fractions that we can quite easily add together because they have the same denominator. So we end up with 7x minus 4 divided by brackets 2x minus 1, brackets x minus 1 equals 1. Now, of course, we've still got what's quite a complex expression in the denominator here, which we don't like. So what we're going to do is multiply both sides by this denominator. Obviously, that gets rid of the denominator here and just puts it on the other side. Obviously, the 1 times by this just is this. So now we have 7x minus 4 equals, and by expanding these brackets out, we do the first of each bracket, so 2x times x gives us 2x squared. The outer multiplication, 2x times minus 1, gives us minus 2x. The inner multiplication, minus 1 times x, gives us minus x. And the last, which gives us minus 1 times minus 1, is 1. Simplifying this down, we have 7x minus 4 equals 2x squared minus 3x plus 1. And then by rearranging this to get this all on the same side, we have 2x squared is unchanged. We have minus 3x and we have minus 7x to get rid of this. Gives us minus 10x. And plus 1 plus 4 to get rid of this minus 4 gets us plus 5 is equal to 0. So this is our standard format now for a quadratic equation. So we can solve this through any method. If you wanted to factorize it, you could. If you wanted to complete the square, you could. But both of those are going to be quite difficult because of the fact that the coefficient of x squared is not 1. So I think the best method here is the quadratic formula. So we know that we have for ax squared plus bx plus c equals 0, x is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. And so, of course, we just substitute in our coefficients. So minus b, so b here is obviously minus 10. Remember the minus in front. So minus b is minus minus 10 or positive 10. And then in the brackets, we have the square root b squared, so minus 10 times minus 10 gives us 100, minus 4ac, so 4 times a, which is 2, times c, which is positive 5, and then we're dividing all that by 2 times a. Obviously, a again is 2, so 2 times 2. Simplifying this a little bit, we have 10 plus or minus the square root of 100 minus 4 times 2 times 5. 4 times 5 obviously is 20, times by 2 is 40, so 100 minus 40, all divided by 2 times 2, 4. So we have 10 plus or minus the square root of 60, 100 minus 40, divided by 4. And we can use a very useful trick here with square roots, is that if we have the square root of some number, we can write it as the square root of two numbers separately that multiply to make that bigger number. So in this case, we can write 10 plus or minus the square root of 4 times the square root of 15, and that's equivalent to the square root of 60. The reason why we do this is because we can see in our answer form we want divided by 2, and right now we've got divided by 4. So we need to divide top and bottom by 2 to get this. So we need a factor of 2 here that we can divide through. Obviously this is already a multiple of 2, so we can just divide that by 2 easily. But obviously we need a square root of 4 to get us this factor of 2 now. So we have 10 plus or minus 2 times square root 15 divided by 4. As I've said, we then divide top and bottom by 2, and that should say 2 in the denominator. That gives us 5 plus or minus the square root of 15, all divided by 2. Question 20 is a mix or a question about circle theorems, but also linear equations. So we're told that we have the center of a circle being the point -1, 3, and a point A with coordinates 6, 8 lying on the circumference of the circle. And we're asked to find the equation of the tangent to the circle at A. And we're asked to give this equation in the form ax plus by plus c equals 0, where a, b, and c are all integers, that's whole numbers. So, first of all, how can we find this equation? So to find the equation of some given line, we can come at it from multiple directions. We could either have a point on the line and its gradient, or we need 2 points on the line. So in this case, we only have 1 point on the line, and there's no way we're going to find any other points on the line because they're not given. So we're going to need this point, and we're also going to need the gradient of this line. So how do we find the gradient of this line? Well, we know obviously that there's a radius from the centre of the circle at -1, 3 to this point on the circumference at 6, 8. And one of our circle theorems is that this radius must meet this tangent line at 90 degrees, right? So these two lines must be perpendicular. An important bit of knowledge here is that the gradients of perpendicular lines multiply to -1. So we can find the gradient of this tangent line. We just need to find the gradient of the radius. So when the radius goes from -1, 3 to 6, 8, it goes along 7 units and up 5 units. And of course, gradient is equal to rise over run. That's change in y over change in x. So that's 5 over 7. So if we say the equation of a tangent is just full of unknowns currently, y equals mx plus c, our standard linear equation form, we can say that 5 divided by 7, which is our gradient of the radius, multiplied by m, the gradient of the tangent, is equal to -1, which we then just simply rearrange by multiplying both sides by 7 over 5, the reciprocal of this, which is going to get rid of this fraction here, obviously gives us m equals -7 over 5. So right now we can update the equation of this tangent to say y equals -7 over 5 times x plus c, where c is our y-intercept that we still don't know. So to help us solve this, we can substitute the one point that we do know is on this line, where we know that y is equal to 8 and x is equal to 6. So we can say that 8 is equal to -7 over 5 times 6 plus c. Now, this is a bit of an annoying fraction, but we can simply obviously multiply this together and say 8 equals -42 divided by 5 plus c. Now, if we turn 8 into a fraction of 5 as well, we can say 40 divided by 5 is equal to -42 divided by 5 plus c. If we now simply add 42 divided by 5 to both sides, we get rid of the instance on this side and end up with c is equal to 82 divided by 5. So our final updated equation is y equals -7 over 5x plus 82 on 5. So that is the linear equation of this tangent, but now we need to put it in the form required. So we need to move all of the terms over to one side, so we just have 0 on the opposite side, and then make sure that all of our coefficients, all the numbers before y and x and at the end, are integers. So we can add 7 over 5x to both sides, which we're going to put over here and get rid of this, and subtract 82 divided by 5 from both sides, which leaves us with y plus 7 over 5x minus 82 divided by 5 equals 0. And finally, to make sure all the terms are whole numbers, we simply multiply by the denominator of both fractions, which is 5, so we end up with 5y plus 7x minus 82 equals 0. And finally, question 21 is a mix of our knowledge of circles and our knowledge of geometry in general. So we have 3 circles, each with radius 4 centimeters, and the centers of circles are A, B, and C, such that ABC is a straight line, and that AB equals BC equals 4 centimeters. So this also means that the edges of the circle centered at A and the circle centered at C touch at B. Our task is to work out the total area of these two shaded regions, and we're to give our answer in terms of pi. So looking into this annotated diagram here, all of these grey lines, the light grey lines, are radii of one of the circles, and so they're all 4 centimeters long. We can see this is true obviously because these lines go from A to a point on the circumference. These 4 lines go from B to a point on the circumference of a circle, and these 3 lines go from C to a point on the circumference of those circles. So we can see here there are four equilateral triangles where all side lengths are 4 centimeters. And effectively, to find the shaded area, we want to take the area of this whole circle, centered at B, and subtract these white areas that overlap. So we need to work out the area of these equilateral triangles and also the area of these small segments around the edges. So to work out the area of the equilateral triangle, we simply use the formula: the area of a triangle is equal to 0.5 AB sine C. So this is if we take two sides that meet at a certain angle and we do multiply those side lengths together and times by sine of that angle, we get the area of the triangle. So we have 0.5 times 4 times 4 times sine of 60 is going to be our area. So that's 0.5 times 4 times 4 gives us 8, and sine 60, one of the exact values you have to remember, is equal to the square root of 3 divided by 2. So we end up with the area being 4 square root 3. So these four triangles all have the area 4 square root 3. To find the segment area, we need to find the area of a sector, that is, one of these wedges, including the triangle, and then subtract the area of the triangle, which is, of course, 4 square root 3. The area of a sector is the angle of that sector, so how sort of wide that slice is, divided by 360, so the fraction of the whole circle, times by the standard circle area formula, pi r squared. So in this case, obviously the angle is going to be 60 divided by 360 times by pi times 4 squared, 4 being the radius. And this gives us 16 pi, obviously from the 4 squared, divided by 6. This 60 over 360 is equal to 1 over 6. So the area of a segment, that's one of these little slices, is 16 pi divided by 6 minus 4 square root 3. We have 4 triangles and 8 sectors, so the total area of the overlapping regions is 4 times 4 square root 3 plus 8 times, and then in brackets, 16 pi on 6 minus 4 square root 3. If we expand this out, we can see that 8 times 16 pi on 6 gives us 128 pi divided by 6, and we have 16 positive 16 square root 3 here, and negative 32 square root 3 here. So they add to make minus 16 square root 3. The area of the circle, quite simply, this is circle B, is pi r squared, so does 16 pi. So the shaded area is, of course, the circle area, subtract the overlap area, so 16 pi minus, and then in brackets, 128 pi divided by 6 minus 16 square root 3. And if we bring those out of the brackets, obviously this is going to be negative, and this is going to be positive. So we get 96 pi divided by 6, that's a rewriting of 16 pi, minus 128 pi divided by 6, plus 16 square root 3. 96 minus 128 is minus 32, so we have 16 square root 3 minus 32 pi on 6, and that is in terms of pi, as was asked. If you look at this numerically, the answer is about 10 square centimeters.